So we're talking about lesson 2-2. So graphing linear equations, our goal is to create a graph given an equation. So we're going to go right from the equation to the graph. And what we're trying to figure out today is, or the essential part of this is, what do the different parts of a linear equation represent on a graph? So if we can look at the equation and then have that picture in our mind of what that looks like, that's kind of our goal. All right. So I'll give you a chance to write this down. If you have the notes, this is already in there. But so when we talk about linear equations, what we mean by a linear equation is just that when we graph, we make a graph of it, it makes a straight line. So that's all they mean by linear equation. It's just kind of a fancy way of saying it, but it just means when we graph it out, it makes a straight line. So we talk about linear equations, we can talk about them in this form, this y equals mx plus b. And most of you have probably already seen this form and know what these things mean. The m here describes how steep the line is. So we talk about that as a slope. And then the b part of it represents where the line touches the y-axis. And then we call that the y-intercept. Okay, and this form is also called the slope-intercept form. All right. One second. Okay, so I'll go into more about what these numbers represent and what they look like. But this is generally the form that we're going to look at, this slope-intercept. So this is the slope, and this is the y-intercept, the slope-intercept form. The x and y in this equation just represent the different points on the line. So for every point, there's an x and a y. And we can calculate, if we have the x, we can calculate what the y is going to be based on the m values and the b values. All right. Okay. So, in your assignment today, you're going to be asked to do a lot of this stuff, right? Just graph these lines and figure out what they look like. And so, if I look at this, right, I've got y equals 3x plus b. This tells me that the line has a slope of 3 and it's got a y-intercept of b. Now, if we know what those are, we know how to use them, we can go ahead and graph this. If we don't know what those are, we can just build a table of values. Okay, and we're going to do it, build a table of values, and then we're going to try to make sure we can see how to shortcut that process, how to go right from the equation to the graph. But if this is my x and this is my y, I'm going to choose some different values for x. So if I put 0 in for x, and I'm choosing 0 because it's convenient, it's easy to calculate, and so if I put 0 in for x, I get 1 for y. So I can see where that point is already. That's going to be 0, 1. I'm going to choose another point here. Let's say, well, let's do easy ones. Let's do 1. If I put 1 in for x, I get 1 times 3 is 3, plus 1 is 4. So I get 1, 4. So 1, 4. And then we look at, let's do -1, kind of classic points to put in there. If I put -1 in there, I get 3 times -1 is -3, and -3 plus 1 is -2. So that would be -2. So I can graph that point. -1, -2. All right. So I've got 3 points there. I can see that those points are kind of making a line, and I could go ahead and draw that line. All right. But what we really care about here, what we really want to see, is the relationship between these numbers, right, and what they represent on the graph. So let me just graph this real quick. Put a line through there. And that line, continues on forever. I just drew it right here just because it's convenient, but I'm going to go ahead and extend that line out. And I can extend the line out here as well.
Hold on.
So I can create a table of values and I can graph that. But our goal is to be able to go right from the equation into the graph, right? We'd like to skip this step just because it's time consuming and we'd like to save some time doing that. So it'd be nice if we could just go from here to here. So what I want to do is I want to look at these numbers here. Okay. First of all, when x is 0, y is 1. That's this number right here. Right? That 1 and this 1 are the same thing. This is our point right here. That's where it crosses the y-axis. Notice that's where x is equal to 0. That's always going to be the case. Okay, so we talk about that y-intercept. We can say, well, it crosses the y-axis at 1. We can also say that y-intercept is the point 0, 1. It's a coordinate. Okay, when x is 0, that's when it'll tell us where that y-intercept is, or that b value. So I can tell here that my b value is 1. Now, we said that this 3 represented the steepness of the line, right? And so the steepness talks about how much the line changes from point to point. And so if we look at these numbers here, if we look from 0 to 1, right, x is increasing by 1. It's going up by 1. And when x increases by 1, well, what happens to y? Well, y increases by 3. And I can see that relationship here too. From -1 to 0, my x is increasing by 1, plus 1. And from -2 to 1, my y value is also increasing by 3. Okay? So I can see that every time x changes by 1, my y value changes by 3. So every time I go 1 in x, I'm going to go 3 in y. Okay? It changes that y value in 3. And we see that here. Every time my x changes by 1, right, when my x goes from 0 to 1, my y value goes from 1 to 4. So this is my 1 and this is my 3. Okay, and so this number right here, this m value, this represents this ratio, and it's 3 to 1. So we would say here that our m value, right, our slope is 3 over 1. So every time x changes by 1, the y value changes by 3. And when we simplify that, we just write that as 3. But that's what we're talking about here. Every time x changes by 1, the y value is going to change by 3. Okay, so we call that the slope. Everybody with me so far?
Hold on.
Okay. All right. Okay. So let's look at this example. Okay, this time we're going to try to do this without building a table of values. And we could build a table of values, but we're going to try to do it without doing that. So we know that our numbers here, right, our b value is -3. That means when x is 0, right, y is -3. So we know that point, that's our y-intercept. And we also know that our m value here is 1/2. That means that every time x changes by 2, the y value is going to change by 1. Okay, so this is my change in my x value and my change in my y value. Every time x changes by 2, my y value is going to change by 1. So I want to go ahead and graph that. So the way I'm going to graph that, I know that it crosses the y-axis at -3. So I'll put that point on there. And I know that every time my x value changes by 2, right, my y value is going to change by 1. So every time x changes by 2, my y value is going to increase by 1. So I can see I can go over 2 in x and up 1 for y. My change in x and my change in y. And now I've got 2 points. Now I can graph that. And so the nice thing is we didn't really have to do any calculations. We didn't have to plug in any numbers. We didn't really have to do much of anything other than just draw those 2 points and create our line. So we can tell a lot just from these 2 numbers. I always think of this as this tells me where to start, and this gives me directions for how to get to the next point. So from this point, I know that I have to rise 1 and run 2. Rise +1, run +2.
Quest recording this, right?
Yeah.
Okay, just curious. Thank
All right. Okay. So here we have a line. Now this line is a little different. So this is a horizontal line. Okay. So I can tell that it crosses the y-axis at 4, right? So I know that when x is 0, my y value is going to be 4, right? So I've got that b value as 4. But the problem is, how do I talk about the changes in here? So I'm quickly going to make a table of values here, and I don't have to calculate anything because I'm just going to read the points off the graph. But I know that 0, 4, right, is a point on there. I know that 1, 4, right, is also a point on there. I know that -1, 4 is a point on there. And if I look at this, it doesn't matter what x value I choose, right? If I choose -9, all right, my y value is 4, right? So I can tell right away that my x value doesn't make any difference here. My x value can be anything. My y value is always going to be 4. And so the way that I would write that equation is I would just say y is equal to 4. Doesn't matter what x is, y is always going to be 4. Okay? We talk about the slope, right? We talk about how much this changes. Well, from here to here, my x value is changing by 1, and my y value is changing by 0, right? And from here to here, my x value is changing by 1, and my y value is changing by 0. And from here to here, go ahead.
I'm sorry, you froze earlier.
Where'd I lose you?
No, the computer froze.
Oh.
I didn't get what you said.
So if I'm just looking at the slope, right? If I look at the changes in the x values, this is changing by 1 and this is changing by 0. My x value here is changing by 1. My y value is changing by 0. If I look from 1 to -9, right? This is actually going down 10. But what happens to my y value? My y value changes by 0. So if I look at this ratio, if I say, well, every time x changes, what happens to y? My slope value is every time x changes by 1, my y value changes by 0. And so I'd say my slope here is 0. So in this equation, if I'm trying to write this out, my m value would be 0, and my b value would be 4. So if I write that out, I would say y is equal to 0x plus 4, right? But 0 times x is always 0, and so we just get y equals 4. Okay.
Thank you.
So these kind of equations, right? This horizontal line, these are one of the most common ones that people miss, right? When we're writing equations, or if we're given an equation, we're trying to figure out how to graph it. those kind of equations are the ones that kind of trip people up the most. Whenever I just have a y value, y equals 4, that means that all my y values are 4, right? And so I'm just going to have a horizontal line. Here we have a similar example. If I look here, it's not a horizontal line, but it's a vertical line. And so if I list out some points here, well, when x is equal to 0, well, x can't be equal to 0, right? X is negative 4. So when x is negative 4, right, y is 0. And when x is negative 4, y is also, whatever, 3, negative 4, negative 2, right? I can see in this equation all my x values are negative 4, right? X can't be anything other than negative 4. And it doesn't matter what my y value is. My y value can be whatever, but my x value will never change. So we talk about these as called constant functions, right? It's just that x is equal to some number or y is equal to some number. We either get a horizontal line or a vertical line. This equation right here, the equation for this line is just x equals negative 4. The y value can be whatever, the x value is always going to be negative 4. If we look at, go ahead. What were you going to say?
Oh, I was still writing.
Okay. If we look at these changes here, right? Here, my y value, in this case, the second one, my y value is increasing by 2, but what's happening to my x values? Well, my x values aren't changing. My x is staying at negative 4, so my change in the x is 0. And the same thing here, this is going from 3 to 0, this is going down by 3, but my my x values stay at 0. So if I want to talk about my slope right here, well, every time x changes by 2, my y value changes by, every time my y value changes by 2, right, my x value is going to change by 0. Or if my y value changes by negative 3, my x value is going to change by negative 0. And what happens here is we run into this situation where we're trying to take a number and divide it by 0. And in math, that's not allowed, right? To divide means to cut into pieces, right? If I say, divide by 4, that means to cut into 4 equal pieces. If I say divide by 0, that means to take something and cut it into 0 number of pieces. And that just can't happen. It's an illogical sort of idea. And so we say in math, we say that this slope is undefined. Right? That math operation of dividing by 0 is not a valid math operation. That operation has not been defined mathematically. In MyOpenMath, right, when you type that in, what we type in DNE for does not exist. Okay? So it does not exist. And the same thing with our b value. If we look at our b value, well, the b value represents where the line crosses the y-axis. Well, this line doesn't cross the y-axis. It's actually parallel to the y-axis. So it's never going to cross the y-axis. So we would say here that this is also does not exist. It's not 0, right? It doesn't cross the y-axis at 0. It just doesn't cross it. So here we have a slope that's undefined. We have a y-intercept that's undefined. Our y value doesn't make any difference. And so the way we define that equation is just x equals negative 4.
So the equation is x equals negative 4?
Yeah. And this is one of the exceptions here, right? This isn't, we can't write this line as y equals mx plus b because m is undefined and b is undefined. So the only thing we have defined is that x is negative 4.
Thank you.
All right. Okay, and then our last example here, we're going to always come back to some sort of situation, right? So here's a situation. Here's a company that's making toys. So it costs them $10 to manufacture each toy. and it says that it cost $7,800 to develop the toy. Okay, and so they want you to write an equation to represent the total cost. Use the value y to represent the total cost, and for the number of toys, and we're going to use x to be the number of toys. So that's our total cost, and x is going to be the number of toys. Okay, now when we look at this, we read through this, this word right here, whoops, that's not what I want to do. This word right here, each, right? Each is very important. Each tells us that this is multiplication, right? When you say each or per, that means multiply. So that means that for every toy we make, we have to add $10 to the overall cost. So if I had one toy, it'd be $10 added to the cost. If we had 10 toys, it'd be $100 added to the cost. We'd multiply the number of toys by 10 to get the cost of the toys. And so if I start writing my equation, I would say, well, whoops, write in yellow. I would say y, right? The total cost is going to be $10 per toy. So $10 per toy. But that's not the only cost. It costs $7,800 to just design the toy. So you got to figure in that $7,800. That $7,800 is a fixed cost. It does not change depending on how many toys we make. So if I have 2 toys, it doesn't cost me twice this. It still just costs me $7,800 to develop that toy, but it's going to cost me $10 per toy. All right. So this is a constant and this is a variable. So depending on the number of toys, I'll figure out the cost here. All right. So here my m value is going to be 10. Right. Every time the number of toys changes by 1, my cost is going to go up by 10, and my b value is going to be 7,800. So what does that mean? That means that if I don't make any toys, right? If I just design and develop the toy but don't make any, I still have to pay that $7,800. Okay, so that $7,800 is fixed. All right, so there's my equation, and then they just ask how much would it cost to make 2,400 toys. So I would just plug that in for x, right? This is 2,400 toys, so my x is going to be 2,400. And so I would have y is going to be 10 times 2,400. My screen's kind of wigging out a little bit. Plus 7,800. And so what is that? 24,000 plus 7,800. I think that's 31,800. Okay, so it cost $31,800 to make 2,400 toys. Okay, and we should be able to graph that as well. We would start with that development cost of $7,800 on the y-axis, and then every time we increase the toys by 1, we'd go up in the cost by 10. So we can graph that as well. All right, so that's all I have for the notes. You can take a look at the assignment